Modern diesel engines, DPF, EGR, AdBlue, regens, sensors everywhere. And a lot of people still saying, diesels are bulletproof, they run forever. Diesel is the smart choice if you drive a lot. That used to be true. But the big, simple, mechanical diesels that would eat bad fuel and do 1,000,000 kilometers, those are mostly gone from passenger cars. What you have now, Euro 5, Euro 6, and Tier 3 era diesels with DPFs and complex EGR are completely different animals. And if you don't understand what's been bolted onto them, they can very easily turn into a financial trap. I'm GearHead. I don't hate diesel. I hate watching people buy the wrong kind of diesel for the way they actually drive, and then drown in DPF, EGR, and injector bills at 120,000 miles. If you want to stop being that person and start reading modern engines like a forensic mechanic, grab my ebook, GearHead Genius, the forensic guide to not getting screwed by your car. The dealership wants $4,500 for a new hybrid battery. My forensic checklist shows you how to save it for $0 with a screwdriver and 30 minutes. The same forensic logic works on DPFs, EGR, CVTs, leaks, all of it. I built this guide for the pragmatic owner who cares about total cost of ownership. One useful tip in that book will pay for it 50 times over. The link's in the description and pinned comment. Copy it into Word, print it, walk it around your car with a flashlight, and if you get stuck on a specific diagnostic, drop a comment on my latest video. Let's dig into why modern diesel engines are a financial trap, and what DPF and EGR are actually doing to your wallet. When someone says diesel runs forever, they're usually thinking of an engine that looked like this: a big displacement cast iron block, a mechanical injection pump, no DPF, little or no EGR, no AdBlue or SCR system, and very simple electronics if any. Those engines were loud, smoky, simple, and easy to keep alive with basic tools. You could idle them all day, run them on questionable fuel, neglect them, and they'd still often do insane mileage, perfect for tractors, old Land Cruisers, vans, and trucks. Modern passenger car diesel is a different thing altogether. It has high-pressure common rail injection, 1,500 to 2,500 bar, or 20,000 to 36,000 psi. It uses multiple pilot and post-injections each cycle. The superfine injector tips hate contamination. It has Exhaust Gas Recirculation, or EGR, to reduce NOx. It has a Diesel Particulate Filter, or DPF, to trap soot. It has Selective Catalytic Reduction, or SCR, with AdBlue or DEF to finish off NOx. It has 4 to 10 sensors in the exhaust for temp, pressure, O2, and NOx. And it has multiple engine control units managing combustion and aftertreatment in real time. That's an emissions machine with an engine attached. The block, crank, and rods might still be as tough as ever, but now they're only part of a bigger system that cares a lot more about how hot the exhaust is, how often you do short trips, what kind of oil you use, and whether regens complete properly. Durability is now shared between the engine, the aftertreatment system with the DPF and SCR, the EGR and intake systems, and the fuel system. Neglect or a mismatch in any of those, and your bank account will notice. A DPF is exactly what it sounds like, a filter in the exhaust that catches soot and particulate matter so it doesn't go out into the air. Inside is a honeycomb of channels, often made of cordierite or silicon carbide. Soot gets trapped in the walls of those channels as exhaust passes through. If you just left it there, it would clog and choke the engine. So the system has to periodically burn that soot off in a process called regeneration. There are two basic ways this happens. Passive regeneration occurs when the engine is under a good load, the exhaust temps are high at 500 to 600 degrees Celsius or more, and you're on a highway, climbing or driving briskly. In these conditions, soot naturally oxidizes on the filter walls. You don't feel it. You don't get a warning light. The engine control unit might not even call it a regen. It's just heat doing its job. Active regeneration kicks in when the engine control unit estimates the soot loading is high from the DPF pressure and other models, and your driving hasn't produced enough passive regen. So the engine control unit deliberately raises the DPF temperature by injecting extra fuel late in the engine cycle, or post-injection, or using a dedicated exhaust fuel injector upstream of the DPF and playing with the EGR and boost to increase the exhaust gas temps. That extra fuel burns in the exhaust, raising the DPF temperature to over 600 degrees Celsius to burn the soot. You might notice a higher idle RPM, cooling fans running, a slight exhaust smell, and your fuel economy dropping temporarily. All of this is normal, if it finishes. An ideal regeneration life is when you drive on the highway. The regen starts and finishes, the soot burns, and the DPF is happy. Real life for a lot of owners means short trips, traffic, shutting the car off right when an active regen starts, and the engine rarely seeing sustained hot operation. This leads to the soot load creeping up, regens starting more often, many regens being cut short, unburned fuel from post-injection sneaking past the rings and causing fuel dilution in the oil, and the oil thinning out, which shrinks the hydrodynamic lubrication margins. Eventually, the engine control unit says, "Soot load is too high. I'd have to overheat the filter to burn this. Not safe." You get DPF warning lights, limp mode with reduced power, and a need for a forced regen with a scan tool, if the filter is too far gone. Or you'll need a DPF replacement if the substrate is cracked or melted. That's not a $100 fix. On many cars, the DPF itself is $1,000 to $2,000 plus. Sensors and labor can be several hundred to over $1,000. And sometimes access requires a subframe or exhaust drop, which means more labor. One DPF job can easily eat years of your fuel savings. And you didn't do anything wrong, you just lived your normal short-trip life in a system that was designed around hot, sustained driving. Now let's talk about Exhaust Gas Recirculation, or EGR. It reduces NOx by taking some exhaust after combustion, cooling it in an EGR cooler, and feeding it back into the intake. That inert exhaust displaces some oxygen in the fresh charge, which lowers peak combustion temperature, slows the flame speed, and reduces NOx formation. So far so good for emissions testing. But exhaust isn't clean. It has soot, ash, oil vapor from PCV or crankcase ventilation, fuel vapor and traces, and water vapor. When this cocktail is recirculated and cooled, it condenses and sticks to surfaces, especially the EGR valve and passages, the EGR cooler, which is a tiny coolant and exhaust heat exchanger, the intake manifold walls, and the intake ports. When the EGR and intake are heavily coked, you lose power, your fuel economy drops, the DPF fills faster, the turbo and bearings are living on thinner oil, and the emissions go out of range, which turns on lights on the dash. Proper remediation is not pour a magic fuel additive in the tank. Real cleanup often means removing the intake manifold, the EGR valve and cooler, soaking and physically cleaning the passages, sometimes baking or chemical cleaning of the coolers, and replacing gaskets and cleaning the ports. The cost is easily $800 to $2,000 in many markets, depending on access and labor rates. Again, that's money you only spend because the EGR system is trying to save the environment in a way your usage pattern doesn't support. Put all this together for a typical owner. Their daily drive is 10 kilometers each way, mostly in the city with some suburban driving. Their car is a modern 2-liter TDI, DCI, HDI, TDCI, and so on, with a DPF and EGR. And their style is gentle, with low RPMs, short trips, and shutting off whenever they arrive. Here's the timeline. From 0 to 50,000 miles, or 0 to 80,000 kilometers, everything's new. The DPF regens quietly, the EGR is relatively clean, the engine feels strong, the fuel economy looks great. You praise diesel to your friends. From 50,000 to 100,000 miles, or 80,000 to 160,000 kilometers, now the EGR and intake restriction is serious. The DPF ash loading is high. The system is fighting constantly just to stay in spec. Then you hit a threshold. An EGR fault leads to limp mode. The DPF can't regen, which leads to limp mode, or the turbo and injectors get dragged down by hot, dirty conditions. You walk into the dealer or a shop, and they say something like, "Your DPF is at the end of its life. The EGR is blocked. The turbo is leaking oil. The injectors aren't happy. We recommend," and they drop a number that looks like a down payment on a house.
At that moment, you realize the fuel you saved was never free. The after-treatment hardware you never thought about has a real, finite service life, and nobody told you that before you signed. That is the financial trap. The engine itself, the thing diesel fans brag about, is often fine. It's the emissions side that died from living your life. Let's be fair, modern diesels are not trash, they're just context sensitive. They still make engineering sense if you do big motorway mileage, 20,000 to 30,000 plus miles a year, or 30,000 to 50,000 plus kilometers a year, if much of that is continuous runs of 30 to 60 plus minutes. If you work the engine by towing, hauling, or at least not babying the throttle at 1200 RPM all day. In that environment, the exhaust stays hot most of the time. The DPF gets lots of passive or well-timed active regens. EGR deposits still occur, but more slowly, and fuel savings add up faster relative to repair risk. You still have to use the exact correct low SAPS oil and not stretch the intervals to the absolute limit. You have to respect warning lights and not bypass them until something explodes. And you should expect some emissions work around 10 plus years or 150,000 plus miles. If you do not drive like that, and your life is short commutes, urban traffic, school runs and shops, and occasional highway driving but not much, diesel is the wrong tool. A full hybrid, like a Toyota, Honda, Ford, or Hyundai and Kia, is the modern diesel for that kind of driving. It's designed to excel in stop and go. It has no DPF. The EGR, if used, is less soot intensive. Electric motors soak up low-speed duty, and they have long, boring reliability records in exactly those use cases. If you're already in a modern diesel and can't or won't switch, you need to change how you treat it. First, help the DPF do its job. Once a week or every couple of weeks, find a safe stretch of highway. Do 20 to 30 minutes of continuous driving. Don't just lug it at 1200 RPM in top gear. Let it see 2000 to 2500 RPM now and then. This helps raise exhaust temps, encourage passive regen, and let active regens complete. If you suspect a regen is happening, with fan noise, a slightly higher idle, or a weird smell, and you're close to home, consider taking an extra lap around the block or give it a few more minutes before shutting down. Don't baby a DPF diesel all the time. It needs some heat cycles. You also need to treat oil as a consumable, not a lifetime fluid. Use the exact spec your engine calls for, like ACEA C3 or C4 or VW 507.00. Do not dump generic diesel oil in there. If your usage is mainly in the city, shorten your change intervals versus the book's max. Long life intervals like 18,000 to 24,000 miles or 30,000 to 40,000 kilometers are fantasy for DPF city cars. Check the oil level. If it rises over time, fuel dilution is likely. It's time to change the oil and ask why regens are so frequent. Thin, fuel-diluted oil is how you turn DPF problems into turbo and cam problems. You should never ignore early EGR or DPF codes. Get a basic OBD2 scanner or have someone scan your car once in a while. Pay attention to DPF differential pressure values, where high at a low load is bad. Soot load estimates, if available, and EGR flow codes like P0401. If you get a DPF or EGR-related code, do not just clear it and hope. Investigate, log, and respond. Early intervention, like a forced regen plus maybe a mild chemical clean and an intake check, can be hundreds now instead of thousands later. Finally, accept their real EGR and intake clean is part of long-term diesel ownership if you are in the wrong duty cycle. On some cars, in heavy city duty, a proper EGR and intake clean at 60 to 100,000 miles might be considered preventative. That might mean taking the intake manifold off, the EGR and cooler off, a deep de-coke and new gaskets. It's not cheap, but it restores airflow and combustion quality, slows DPF loading, and can add years to the usable life of the emission system. If this was 2002 when you did big miles, buy a diesel was the default smart answer. In 2026, that's changed. Now the first question is, how do you actually drive? If your life is 80% highway with long runs, occasional towing, and minimal traffic, diesel still has a case. If your life is mixed short trips, a lot of urban and suburban use, and modest annual mileage, then a full hybrid or a clean, efficient gas engine is the modern equivalent of the safe choice. Hybrids take the same inefficiency domain of the city and solve it by recovering energy with a motor, using Atkinson cycle engines and avoiding DPF and complex EGR in most cases. They're specifically built to live where modern diesels now die. Modern diesels have become niche tools. The trap is that they're still marketed like they're universal tools. If this helped you see DPF and EGR not as random annoying parts, but as the center of the modern diesel money equation, and you want a structured way to protect yourself from this kind of thing, that's exactly why I wrote my ebook, GearHead Genius, the forensic guide to not getting screwed by your car. The dealership wants $4,500 for a new hybrid battery. My forensic checklist shows you how to save it or stretch its life for $0 using the same kind of forensic thinking we just applied to DPF and EGR. Inside, you get the lifetime fluid lie, real intervals for ATF, AVT, and diff oils, Honda VCM and Subaru gasket survival tricks, exhaust and underbody hacks that turn $400 jobs into $4 fixes, how to spot early leaks and weak points on V6s, V8s, and EcoBoosts, hybrid battery and turbo survival moves, where to clean, what to inspect, a dealership BS translator, exactly when to say no, and a 300,000-mile master maintenance schedule and a 10-minute weekly walk-around checklist. It's built for owners who care about total cost of ownership, not just what's my payment. Stop the dealership BS and take control of your machine. Hit the link in the description or pinned comment, copy the guide into Word, print it, and take it out to the car with a flashlight. If you run into something that doesn't make sense, a weird fluid, a noise on cold start, a code you don't understand, drop it in a comment on my latest video. That's where I pull real-world cases for new deep dives. I'm GearHead. Every engine has a story, and together, we're going to make sure yours doesn't end with a DPF light, an EGR fault, and a repair quote bigger than the car is worth.